Hello students, I welcome all of you to Infinity Learn JEE channel by Sri Chaitanya. So students, what we are going to start now is the discussion of 30th January shift 2, and we'll be looking into each and every question which was asked in this shift 2. Overall level of shift 2 for physics was around mediocre level. What I can say is not very easy questions were asked. Questions were good of the mediocre level, and as compared to the previous shifts, this was having some good questions as well. So it was easy to moderate level, and now let's start with the discussion of the very first question which we have over here. So this question was asked from Vernier caliper. Now if 50 Vernier divisions are given, and they are saying it is equal to 49 main scale division of a traveling microscope and one smallest reading of main scale division. One main scale division they have already given. The Vernier constant of traveling microscope is simple question. Vernier constant means the least count. So what you need to calculate is basically 1 MSD minus 1 VSD, and MSD was given, and also the ratio was given that basically your 50 VSDs were equal to 49 MSDs. So based on that, option number 3 is the correct answer over here, and I hope all of you must have solved it. Is it clear? Just a minute. No, not option number 3, rather it's going to be 0.01 mm. This is the correct answer. Option number 4 is the correct answer, not option number 3. Okay, this is going to be the correct answer, right? You can see this also over here. 0.5 minus VSD will be MSD upon 50. So it will give you the correct answer over here. Okay, done, sir. Now let me solve this also. Just a second. 1 MSD they were saying 50 VSDs is basically equal to 49 MSDs, right? So 1 VSD will be equal to 49 by 50 times MSD. Now least count or the Vernier constant will be 1 MSD minus 1 VSD. So 1 MSD minus 49 by 50 of MSD will be main scale division divided by 50 only, and main scale division is given as 0.5 mm, right, divided by 50. So correct answer will be 0.05, that means 0.01 mm. Yes, obviously option number 4 is the correct answer over here. I hope you all have understood. Option number 3 is just a mistake. Now moving ahead for the next one. A block of mass 1 kg is pushed up a surface inclined to horizontal at an angle 60 degrees. This was an easy question. By a force of 10 Newton parallel to inclined surface as shown in figure, when the block is pushed up by 10 meters. So 10 meters is the distance by which the block is moved along inclined surface, the work done against frictional forces. This one is what a very easy question. Basically, you just need to calculate whatever is the work done against friction. So the friction force over here is obviously going to be nu mg cos theta, and times the distance also they have said it's 10 meters. So it's actually very simple, and the option over here is going to be 12 joule. It's simple. Nu mg cos theta will give you the answer. This is going to be the work done by friction force, and that obviously is going to be 5 joule. Okay. So maximum friction force, obviously during motion, the limiting friction force will work over here, and the limiting friction force will work in the backward direction. Okay. And Fk is nu mg cos of theta. So the work done is simple, and I hope maximum students have got the correct answer over here. That's option number 2. Moving ahead for the next one. For the photoelectric effect, the maximum kinetic energy Ek of the photoelectrons is plotted against the frequency nu of the incident photons. Okay. The slope of the graph gives. So this is basically the maximum kinetic energy, and this is the frequency of the incident photons. Obviously it starts from this point, and this is known as the threshold frequency, right? All of you know this. Now what we need to find is the slope of the graph gives. What actually is the slope of the graph giving? So if I try to relate the kinetic energy with the value of the incident photons, so it turns out to be Ek equals to h nu minus the work function, right? Minus the work function. And along y, this has been plotted. Along x, the frequency has been plotted. So I can just relate it like y is equal to mx plus c. And this being our intercept, your intercept can actually be calculated if you just shift it over here. And m over here will be representing your h. M over here will be representing your h. So I hope this pointer is crystal clear to all of you. And obviously, what is the slope going to give you? Answer is option number 4, that is Planck's constant. So this was also an easy question if you are knowing photoelectric effect. So in all the shifts, if we speak of, questions from modern physics were quite common. And as is an analysis made out from all these shifts, Modern physics is definitely going to be a very hot topic from which questions in next session are also going to be asked. And further, all the people who are aiming for the JEE Main sessions in the coming years, you should focus more towards the modern physics section. Two reasons. First, it's very easy, and next, it's a hot topic and most of the questions are asked from it. Now, another question, block of ice at -10 is slowly heated and converted into steam at 100 degrees centigrade. Which of the following curves represent the phenomena qualitatively? It's extremely easy. This graph over here is going to showcase the exact graph between the temperature as well as the heat supply, right? So they are saying it is present at -10. -10, first it will go over there, then heat is supplied, then it will go over there, and then finally steam has been formed, right? So converted to steam at 100 degrees centigrade, 100 degrees, so it should stop at 100 degree. This point over here is 100 degrees steam. This point over here is 100 degrees steam. So option number 4 is the correct answer over here, right? Is it clear? And so temperature turns out to be constant over here. I hope this is clear to everyone. Okay, answer number 3 is not the correct answer over here. It's option number 4. Which one is the correct answer? It's option number 4. It's option number 4. Option number 3 is obviously not the correct answer. Here, things are not written correctly. Option number 4 is the correct answer over here. Okay. Now moving ahead, this is a schematic graph which is showcasing things over here. Now in a nuclear fission reaction of an isotope of mass capital M, 3 similar daughter nuclei of same mass are formed. The speed of a daughter nuclei in terms of mass defect delta M will be. So simple approach, initially the entire nuclei was at rest and finally it is breaking up into 3 daughter nuclei. So this is capital M and it is breaking into 3 daughter nuclei. So 3, 3 and 3. Let's say the mass is small m dash and small m dash, right? Now we need to calculate the speed of the daughter nuclei in terms of mass defect. So point is initially it was at rest and now they will be having some velocity. The velocity will be in such a manner that it is perfectly cancelling and basically the net momentum is equal to 0. But we don't need to solve using that approach. The main concern over here is since the nuclei is breaking, there is obviously going to be some mass defect. Some mass will get converted into energy. And whatever is the mass which is getting converted into energy, that instead will be equal to the kinetic energies of the daughter nuclei. So simple approach is that whatever is the energy released because of mass defect converting into energy, that will be the individual kinetic energies of all the 3 over here. And based on that, the correct answer over here is obviously going to be option number 3. Option number 3 is the correct answer. Solution is just given over here and you can see the correct answer over here is going to be option number 3, that is C, under root of 2 times delta M upon capital M. Okay. Moving ahead for the next one, choose the correct statement for process A, B shown in figure. Now, so these 2 curves were given and these 2 curves can be any values. So we need to check which one of them is correct. Now over here, two options are actually satisfying A and B over here. There are 2 options. One is option number 1 also, and even option number 2 is also, 3 is also satisfying the same thing. Even option number 3 is satisfying the same thing. 1 also and 3 also. 1 also is there, 3 is also there. I'll just let you know how it is. So basically, the first option is saying PV dash is equal to constant. The second one is saying PV equals to constant for A. So obviously this can act like an isothermal process. And yes, this can act like PV dash is constant, wherein the dash can be equal to gamma, right? This can act like an adiabatic process and this can act like a isothermal process. In adiabatic is more steeper also. So this is perfectly fine. If the value of this dash is greater than, this is dash. If the dash value is somewhat greater than, if the dash value is somewhat dash, we don't know what dash represents over here. The dash can represent any value which is greater than 1. Okay. So if that is greater than 1, then obviously this is perfectly fine, right? Now talking about the third one, so PV raised to the power gamma minus 1 upon T raised to the power gamma equals to constant is representing process B. Now this equation is of an adiabatic process and T equals to K, that means temperature is constant, is representing pressure A. So obviously this is representing isothermal and B is being represented by by adiabatic also. What you can just see over here, that PV raised to the power gamma is constant for adiabatic. Just writing V as nRT upon P raised to the power gamma is constant. What you can simply write down, P raised to the power 1 minus gamma into t raised to the power gamma is constant, right? Take this over here and take this over here. So 1 upon p raised to the power 1 minus gamma into t raised to the power gamma is also constant only. I hope this is clear. And this will go over there. So p raised to the power gamma minus 1 into t raised to the power gamma. This is also a constant entity. Am I clear or not? So this is what they are representing. This is what they are representing. This is constant. So yes, this is representing an adiabatic process. And this obviously can be an adiabatic process, right? And this can be an isothermal process. And obviously adiabatic are more steeper. So this is also correct. This is also correct. Both of the options are correct. So either it's going to be a bonus over here, or basically amongst 1 and 3, whichever is the correct answer, you will get the correct +4 marks. Now moving ahead, as you can see over here, now an electron revolving nth or Bohr orbit has magnetic moment nu n, and this nu n is directly proportional to n raised to the power x. The value of x is, so simple approach is that magnetic moment, if I talk about magnetic moment, is simply equal to NIA. It simply equals to NIA, whatever is the number of loops, current into area. Now number of loops is obviously 1. Current can be written as the charge upon time into area is pi into Rn square, and the time period of the nth orbit. They are talking of the nth orbit. Now time period of the nth orbit is simply 2 pi upon omega. So E upon 2 pi into omega n into Rn whole square, and take the pi over here. Pi will get cancelled. Omega n and Rn. Omega n is simply equal to Vn upon Rn. So E upon 2 into Vn upon Rn into Rn, right? Square. This square will cancel. Finally, what you can see is this magnetic moment, which is represented by nu, is coming out to be directly proportional to E by 2 into Vn into Rn, right? And Vn you already know is dependent upon Z by n, and Rn is dependent upon or directly proportional to n square by Z. So finally mu will be directly proportional to n raised to the power 1, and that x value we needed to calculate. Answer is option number 2. Okay, the same formula has been depicted over here. You can directly see this as a formulation also, or I've given you the direct relation if you can derive from this. Okay, moving ahead for the next one. An alternating voltage V 220 sine 100 pi t volt is supplied to a purely resistive load of 50 ohm. Okay, the time taken for the current to rise from half of the peak value to the peak value is simple process. Whatever is the current, it's a sinusoidal function, and the time period required will simply be equal to 3.3 millisecond. Okay, it's a simple process. You just need to take from I naught by 2 to I is equal to 0, and you will get the answer. Whatever is the values, they have been calculated very easily. You just need to take, see, the current in a purely resistive circuit is in the same phase as is the potential. So potential over here is 220 sine 100 pi t, and current over here is simply going to be I equals to I naught sine of 100 pi t. Done. So based on that, you can very easily find out the answer. Moving ahead, a block of mass small m is placed on a surface having vertical cross section given by y is equal to x square by 4. So this is a cross section. Basically, this is a surface, the equation of a surface. If coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping is. So basically, this is a question of Newton's laws of motion, and the correct answer over here is answer number 1. And what you just need to do is, for this curve, for whatever curve, this is a parabolic curve, right? X square is equal to 4ay. X square is equal to 4ay is basically going to be a parabola. X square is equal to 4ay is going to be a parabola simply like this, right? Where y will be there, and the particle will be situated somewhere over here. So first thing, you need to find out the slope value, and based on that you will be able to calculate this value of theta. And ultimately what you need to do is, you need to take the component of mg acting over here and the normal component which will be balancing the friction force. So this friction force will be balanced by this mg component. Based on that, you will be very easily able to find out the answer, and the correct answer over here is going to be y is equal to 1 by 4 meter. Okay, simple aspect is this, right? At equilibrium, basically when you will take out the components over here, when you will take out the components, this component of mg you will calculate and balance with this friction, you will get the value of nu is turning out to be equal to tan theta, and tan theta you can very easily calculate by dy by dx. I hope this solution is crystal clear. It's a very standard problem. It has been asked earlier also. Now if the total energy transferred to a surface in time t is 6.48 into 10 to the power 5 joules, then the magnitude of total momentum delivered to this surface for complete absorption is. Now complete absorption they are talking about. They're talking about complete absorption. Purely reflection they're not talking about, they're talking about complete absorption. Now in complete absorption, what happens over here is, the energy is simply equal to P into C. The energy is simply equal to P into C. And they have given you the value of energy transferred to a surface is 6.48 into 10 raised to the power 5 joules. So energy value they have given. Now they're just asking about the total momentum. So the energy over here is simply going to momentum into the speed of light, right? Right? So P will be equal to energy upon C. Direct relation, you will get the answer is 2.16, and obviously option number 2 is the correct answer over here. Okay, direct relationship. In place of complete absorption, if there would have been reflection, then there would have been 2 over here. Okay, so 2 E by C. Now, a beam of unpolarized light of intensity I naught is passed through a Polaroid A and then through another Polaroid B, which is oriented so that its principal plane makes an angle of 45 degree relative to that of A. Maloo's law is working over here. The intensity of emergent light is, so basically the intensity of emergent light, this is an extremely standard case taught to you in polarization, and there are 2 Polaroids kept. Initial is I naught, then I naught by 2, and then passes over it. So cos square theta will come over here. Obviously option number 1 is the correct answer. And this is a very standard case wherein, I'll just show you the diagram. So initially unpolarized light is there, it passes through this Polaroid, so only I naught by 2 comes over here, and then when another passes through another Polaroid, so this light ray will come, and this will be cos square theta times of this one. So I naught by 2 into cos square 45 degree. This was a very standard case. Cos square 45 is 1 by 2, so I naught by 4 is the correct answer over here. I hope you have understood this case, and yes, option number 1 is the correct answer. Right. Moving ahead for the next one. So next question over here is escape velocity from gravitation from Earth is 11.2 kilometer per second. I know that. If the radius of a planet be 1/3 the radius of Earth and mass be 1/6 that of Earth, the escape velocity from the planet is. So basically escape velocity is what? Escape velocity is under root of 2 times gm upon r, right? Now they're changing the radius of the planet and they're changing the mass of that planet, and they're asking about the escape velocity. Simple problem based on this explanation, and obviously option number 4 is the correct answer over here. The explanation is as in front of you. It's a very standard case. So escape velocity by root 2, that's going to be 7.9 kilometer per second. If I talk about a particle of charge minus q and mass m moves in a circle of radius small r around an infinitely long line charge of linear charge density lambda, then time period will be given as. So basically what is happening over here is, a particle of charge minus q and mass m moves in a circle of radius small r around an infinitely long line charge of linear charge density lambda, right? The time period will be. Okay, so what is happening over here is the line charge is actually applying a force on this charged particle, that is minus q, and obviously this force is attractive in nature towards the circle. Now whatever is the attractive force, this is acting like a centripetal force over here. And since it is acting like a centripetal force, so whatever is the electrostatic force of attraction, that you need to replace and equate with the centripetal force, and the centripetal force over here will be m omega square r. Through that you can very easily find out the value of time period, and based on that the correct answer over here, what you will get is option number 2. Option number 2. Oh, I hope this is clear. See, mv square by r is equal to lambda upon 2 pi epsilon naught, the electric field, into q by r. Okay, so based on that you can very easily find out the value of time period. Okay, 2 pi upon omega mv square by r, right? So through this you can very easily find out the answer over here. This instead is going to be v by r. This is going to be v by r. That is the reason r has been placed over here and another is represented over here. Okay, just try to solve this, just try to relate both of them, you'll get the final answer, and it obviously is going to be option number 2 over here. Done. Moving ahead for the next one, if mass is written as m is equal to k cp g raised to the power minus 1 by 2 and h raised to the power 1 by 2, then the value of p will be, what is going to be the value of p? So dimensional analysis, simple. Constants have their usual meaning with Ka dimensionless. K is dimensionless, this is dimensionless, this is dimensionless, and over here C has meter per second, G is gravitational constant, this is Planck's constant. So based on that, what you will get the value of C, P is option number 1, that is 1 by 2. Okay, so pure dimensional analysis is happening over here, nothing apart from that, and P will be the value equivalent to 1 by 2. Done, sir. Moving ahead, in the given circuit, the voltage across load resistances. So over here, you need to understand what is the standard potential difference across this germanium diode and this silicon diode, and based on that, this effective potential difference across these two will be 14. This is 0.3, 0.7, and 14 volt will now be the effective potential difference across it, which you can very easily find out. This is the formulation, right? So 15 minus 0.3 plus 0.7 will be equal to this much, and this is kilo into I. So finally, the current which you will get is equal to 7 by 2 milliampere. And if the current is known, then we needed to calculate the potential difference across it. So 7 by 2 into 2.5, the answer will be 8.75 volt. Okay, simple approach. This is the question based on semiconductors. Now moving ahead, if 3 moles of monatomic gas, is mixed with 2 moles of a diatomic gas, the value of adiabatic constant gamma for the mixture is. So it's simple. The process is written over here, that the final gamma of the mixture, this is basically the degree of freedom of the mixture. Okay, so degree of freedom of the mixture they are calculating, and if you have calculated the degree of freedom of the mixture, then gamma simply is 1 plus 2 by f. One approach is this. Another approach over here is gamma of the mixture can actually be calculated as N1 Cp1 plus N2 Cp2 for n number of gases into Nn Cpn whole divided by N1 Cv1 plus N2 Cv2, and this carries on. So this is one more method to find out the Cp1 and Cv1 for monatomic gas and diatomic gas. Based on that also you can find out. Okay, the value of gamma are already given. So the correct answer over here is option number 3 based on the calculation which you are finding over here, 1.52. Moving ahead for the next question, there are 3 blocks A, B and C, and they are pulled on a horizontal smooth surface by a force of 80 Newton. Okay, as shown in the figure. Very simple question, extremely simple, on laws of motion. So this is the second question which we are seeing on laws of motion. So laws of motion has shown some importance in this shift. T1 and T2 we need to calculate. Simple approach, we need to take down the free body diagram of all of them, and first of all we need to consider what is the acceleration of the entire body. So 5 plus 3, 8, 8 plus 2 is 10, 80 by 10 will be 8 meter per second square, and then just take the free body diagram. It's very simple, very easy to find out. The correct answer will be option number 1. Okay, so simple approach is nothing new in it, right? So this is how you are going to find out the value over here. Moving ahead, when a potential difference V is applied across a wire of resistance R, okay, it dissipates energy at a rate W. If the wire is cut into 2 halves, okay, so length is halved, and these halves are connected mutually parallel across the same supply, the energy dissipation rate will be. Simple it is, you have cut, so the radius will be half. Now you are applying in parallel, so the further R equivalent will be another half, R by 4. So now they are asking the energy dissipated rate will be. The potential difference is V only, so V square upon R by 4. It's obviously going to be option number 4, that is 4 times what? 4 times of the previous value. If earlier the rate was W, it's now going to be 4 times, because the radius is decreasing by 4, right? Potential difference is as it is, okay? So it's very simple, the radius is decreasing by 4. First, by cutting into half, radius is getting half, then by attaching in parallel, it is further getting half. This is the scene which is happening, right? This becomes R by 2, this becomes R by 2, and the equivalent becomes R by 4. So R equivalent becomes R by 4. And the power, since you are using the formula V square by R, so it is inversely related to R. So if radius is getting, the resistance is getting by 4, so power will be 4 times. Moving ahead for the next one over here, we need to find out, we need to match them. So Gauss law of magnetism, what is Gauss law in magnetism or magnostatics? Sir, it is obviously integration of B dot dA is equal to 0. So A option obviously is matching with the second one. A option matching with the second one is only present in option number 4. Through that only you will get the answer. But further you can relate B, Faraday's law of electromagnetic induction. B is equal to third. Integration of E dot dl is minus of d by dt, d phi by dt. Obviously this is EMI only. So B is third. Then C, Ampere circuital law. C will be, where is Ampere circuital law? This is Ampere circuital law. So C for 4, bilkul sahi. right? And D, Gauss law for electrostatics. Gauss law for electrostatics is integration of E dot dA is equal to Q enclosed upon epsilon naught, right? Q enclosed upon epsilon naught. This is the correct answer. So obviously option number 4 is the correct answer over here. I hope you all have understood this. Right, these are the formulas written, so it's very easy, not an issue at all. Projectile A and B are thrown at an angle 45 degree and 60 degree with vertical respectively. With vertical, this is a keyword over here. This you should not forget, from 45 to 60 respectively, from top of a 400-meter high tower. If their ranges and times of flight are same, the ratio of their speed of projection VA is to VB is. Simple process, you are just throwing from a particular height at two different elongations, and the time and the range, they are same. The time and the range are same. So just by drawing down the components, you will be very easily able to solve this up, and the correct answer over here is going to be 1:√2. Simple process, nothing much to worry about. And basically for the same time of flight, yes, for the same time of flight, vertical component of velocity of projectile must be same. Yes, the vertical component should be same. The vertical component should be same. Absolutely correct. So different velocities, VA sin 45 should be equal to VA sin of 30, right? And one more thing, what students have done the mistake over here, in a hurry manner, they have calculated this as 60 and 45 degree. Rather, this is going to be 30 degree and this is going to be 45 degree over here. Okay. So they have given the angle of 45, 60 with vertical, right? So with horizontal, it's going to be 45 and 30. So option number 4 is the correct answer over here. And even without this approach also, you could have solved, just took same time 2u sin theta upon g. Or sorry, not 2u sin theta upon g. With the help of finding out the components, you can very easily find out the height is same for all of them. The height is same for all of them. So based on that, you can very easily find out what is going to be the time period in both the scenarios. Okay. Now, moving ahead, a power transmission line feeds input power at 2.3 kilovolt to a step-down transformer, okay, with its primary winding having 3000 turns. The output power is delivered at 230 volt by the transformer. Okay, so obviously this is a step down, so the output potential is lesser than the initial one by the transformer. The current in the primary of the transformer is 5 ampere and its efficiency is 90%. That means whatever is the initial power, only 90% of that initial power is being transferred to the secondary coil. The winding of the transformer is made of copper. Okay, the output current of the transformer is simple. The Vs into Is is just equal to 90% of Vi into, or Vp into Ip. That means of the primary coil. And Vp is this. This is your Vp, the primary coil. Vs is this. Where is Vs? This is Vs. Another thing, the current in the primary of the transformer is 5 ampere. This is Ip. Now I think you can very easily find out the value of Is, because that's the thing which they are asking. This is the only thing which they are asking. Okay. So answer will be equal to 45. This is an integer type of a question. This is which question? This is, sir, an integer type of a question. Answer number 45 is the correct answer over here. Okay. Based on this, you will get the value as 45. I hope I am clear to everyone, right? Now moving ahead for the next one. A big drop is formed by coalescing 1,000 small identical drops of water. Okay. If even be the total surface energy of 1,000 small drops and E2 be the surface energy of a single big drop of water, then E1 is to E2 is X is to 1. E1 is to E2 is X is to 1, where X is, how much is X? How much value is X of? So basically, surface tension into whatever is the surface area, that is basically the surface energy. And you can very easily find out the area. Their volumes are going to remain same. 1,000 small identical drops are merging to form a bigger drop. So with that, you can very easily relate their radii. And once you have related the radii, then the ratio of the energy simply equals to surface tension into the surface area. Okay. So correct answer over here is option number 10. What is the correct answer? Option number 10. Okay. This is the methodology which is used over here. Based on volume conservation, or basically volume is same, capital R will be equal to 10 times small r, and you can very easily find out the answer. Moving ahead for the next one, two discs of moment of inertia, I1 equals to 4 kg meter square and I2 equals to 2 kg meter square, about their central axis and normal to their planes, rotating with angular speed 10 radian per second and 4 radian per second respectively, are brought into contact. Okay. with their axis of rotation coincident, the loss in kinetic energy of the system in the process is. Simple problem. It's a question of conservation of angular momentum. Okay, both the disks after they are touching each other will move with a common angular velocity, and you can very easily find out there is definitely going to be a loss in the kinetic energy, and that loss, see, by angular conservation we have calculated the value of omega, and loss in kinetic energy will be initial kinetic energy minus the final kinetic energy. Okay, so what is the correct answer over here? So correct answer is 24 joules, right sir? Moving ahead, in an experiment to measure the focal length of a convex lens, the magnitude of the object distance x and the image distance y are measured with reference to the focal point of the lens. Focal point of the lens. Focal point of the lens, we have measured the x and y from the focal point of the lens. The y and x plot is shown in figure. So if you just look at this graph, you will see there is a point 20 and 20 at which the object distance is equal to the image distance. That means whatever position the object is placed there, the same position the image is being created. This position obviously is 2f, right? But 2f is the distance from the optical center. Here the distances are from the focal point only. So that means what is this 20 and 20 is basically the distance between f and 2f, that is f only. So f value is known, that is 20, and they are asking about the focal length of the lens only. So the correct answer is 20 over here. I hope this is clear, right? So based on this also, you can very easily find out. Okay. Now sir, moving ahead. I think this is not the correct answer. U and V will be equal to not 20 and 20, rather they will be equal to minus 40 and 40. Now based on that, you will get the value as 20 centimeter. Okay. Now a vector has magnitude same as that of A vector and is parallel to B vector. So from B vector, we need to find out the unit vector, that is 4i plus 3j divided by the magnitude of B, and the magnitude under root of 4 square plus 3 square will be 5. So 4i plus 3j by 5. This is the unit vector. Through this we calculate the direction parallel to this. And magnitude is over here, 3i plus 4j. So multiply 3i plus 4j and you'll get the answer. And the first quadrant they're asking, what is the value of x and y? X obviously is going to be equal to 4 only. So correct answer is 4 only. I hope this is clear. It's a very simple problem. It's a very simple problem asked from you, and this is the correct answer. Okay. Moving ahead for the next one, the current 5 ampere flows in a square loop. Yes, sir. Sides 1 meter is placed in air. The magnetic field at the center of the loop is. At the center of the loop, what do you think is going to be the magnetic field line? So at the center of a loop, the magnetic field line will be because of all of them, right? So simple formula, mu naught upon 4 pi I sine of theta 1 plus sine of theta 2. And once you have calculated that, you need to calculate whatever is the angle, right? So whatever is sine theta 1 and whatever is sine theta 2, and obviously it is going to be 45 and 45. And whatever is the value, you need to do the 4 times of that, because of all of them, it's going to be in the same direction. So based on that, the simple formulation, answer 40 is going to come. Unit upon 4 pi r sine of theta 1 plus sine of theta 2 into 4, as I have told you. Simple approach, nothing different over here. You can very easily find out the answer. Moving ahead for the next one, 2 identical charged spheres are suspended by strings of equal lengths. The strings make an angle of 37 degrees with each other. When suspended in a liquid of density 0.7 gram per centimeter cube, the angle remains same. Now, why the angle is remaining same? In both the scenarios, earlier the angle was 37 degree, right? Earlier the strings make an angle 37. This is 37. And now also it is making 37 only. That means whatever is the decrement over here, what is going to happen? FB will act, buoyant force will act, but along with that, this FB will make the strings move far away from each other. This FB will make the strings move far away from each other, but the electrostatic force, the electrostatic identical charge sphere, the electrostatic force which was making this, that will also reduce. The electrostatic force will also reduce. Why it will reduce? Because the value of K will reduce. Earlier, the electrostatic force was responsible for making the strings move at an angle 37 degree, but over here now it will reduce and this FB will increase. So it's just forces, balancing the forces. It's simple balancing the forces, the net force over here and the net force over here. You will get the answer. So dielectric constant of the liquid we needed to calculate. You need to solve equation for this and equation for this, and based on that what you will see is the correct answer over here is turning out to be answer number 2. The correct answer over here will turn out to be answer number 2. Answer number 2 is the dielectric constant as is given over here. Okay, so simple approach. Now a simple pendulum is placed at a place where its distance from Earth's surface is equal to the radius of the Earth. If the length of the string is 4 meter, then the time period of small oscillation will be. So time period is 2 pi under root of L by G, right? Now what is going to happen is, at the surface of Earth it's going to be G, but at a height which is equal to the radius of Earth, above the surface of Earth, obviously the acceleration due to gravity will change, and the formula which will help you to find out is G1 plus h by r whole square, right? Yes sir. So you need to find out this G value at a height h, and when you will place it over here you will get the value of time, right? So that is the time period of the small oscillation which we need to calculate over here. Okay, I hope this is clear to everyone. So based on this you will get the answer as option number 8. This is going to be the time period of small oscillation. Simple approach has been expressed over here. The next question, a point source is emitting sound waves of intensity 16 into 10 to minus 8. Over here it should not be intensity, rather it should be the power rating. A source is always given with a power rating. Intensity is the quantity which we calculate. So they have given the intensity which is wrong. The difference in intensity magnitude only at 2 points located at distance 2 meter and 4 meter from origin respectively will be. So this portion is correct. We can very easily find out the value of the intensity. Intensity is simply power upon 4 pi r square, and through this we can very easily calculate the intensity at 2 meter also and 4 meter also, and we need to subtract them. But the point is, what initial data they should give is not intensity, rather it should be power rating. Because for sources, for everything, the power rating is given. That is, what is the energy which is getting radiated out per second. So this is a bonus question over here. You are going to get bonus. There's no correct answer for this. Basically, if you consider this to be a power, remove this meter square over here, then this works. But in my sense, you will get the answer as a bonus over here. This you will get as a bonus. Okay. I hope this is clear to everyone. Moving ahead for the next one, two resistors of 100 ohm and 200 ohm are connected in series with a battery of 4 volt and negligible internal resistance. Okay. The voltmeter is used to measure the voltage across 100 ohm resistance, which gives the reading as 1 volt. The resistance of the voltmeter is. So basically there are two resistors which are applied across a battery, and this one was 100, this one was 200, and across this a voltmeter is there, which voltmeter is also having its resistance of itself as well. Now the reading which it is giving is 1 volt. So 1 volt is the potential difference over here. This is 1 volt. This is 1 volt. So if 1 volt is there and this reading is given as 4 volt, right? So obviously the reading over here will be 3 volt. 3 plus 1, that is 4. So based on 3 you can very easily find out what is the value of current I over here. Based on 1 you can also find out what is the value of current over here. When you will subtract this current from this current, you will get the value of current which will run in this circuit. And once you know the current, the potential difference will be 1 only. So current, the potential difference divided by current will give you the value of resistance. And based on this simple approach, you will get the answer as 200 ohm. You will get the answer as 200 ohm is the potential difference of the voltmeter. So this simple approach is being used over here. Okay. Now with this, we come to an end to all the questions which were asked in 30th January shift 2. I hope you have understood each and every question, and basically I have given a very good hint over here how you can approach this question. And to all the students out there who are preparing for the next session of JEE Main and also the coming years, you should try to practice these questions, try to solve them, get to the final answer. This is a personal suggestion from my end to actually develop your exam skills. You should understand this thing, that this was the paper asked during that exam. And my personal advice is going to be that please give this paper in that scenario, and for any doubts you can refer to this video. So we'll be meeting again with more discussion about the other shifts of first session of JEE Main 2024. That's going to be all from this session. Thank you, bye bye, and take care all of you.